Hello and welcome back. In this video, I'm going to take you through a very brief overview of energy, wavelength, and frequency when we talk about electromagnetic radiation. I might say light, but I really mean electromagnetic radiation. So the photoelectric effect, in very brief terms, was discovered by Einstein back in published in 1905 or so. And it was this discovery that light of only certain wavelengths are able to knock an electron off of an atom. So in this experiment, light kind of acted as a particle. It's kind of like throwing a ball at an atom and then knocking an electron off one of the orbits. And some experiments showed light as waves, some as particles, and this kind of like clinched the idea that light has a wave-particle duality, which means that sometimes it acts as a particle, sometimes it acts as a wave. Now, the Einstein-Planck equation shown here, E equals h nu, that little v that's kind of curling to the side is pronounced nu. It's a Greek letter in the Greek alphabet. And h is Planck's constant, okay? And we attribute great things to Planck, but really this was just a fudge factor. It was just a curve-fitting kind of number, and we don't even know what really physical significance it has. It's just a number that shows up in a lot of different physics and here in chemistry. So Lewis, we'll learn later on about Lewis structures, but Lewis was the one that coined these photons. Hey, have you ever heard of the term photon torpedoes from Star Trek? Well, anyway, that's where this idea came from, okay? Now, one other concept I need to teach you about is the speed of light. The speed of light is constant. It's very fast. It's 3.00 times 10 to the 8th meters per second if we round it off to 3 sig figs. And that's, I think, 286,000 miles per second. Very fast. Sunlight from 93 million miles away or so reaches us in about 8 1/4 minutes. So it's very fast. Now the speed of light equation right here, you want to memorize this. C is equal to lambda times nu. Lambda is that kind of upside down Y. That's called the wavelength of light. And it can be in 3 different kind of units we use a lot in chemistry. We use the meters. We use nanometers, which is a billionth of a meter, 10 to the minus 9th meter. Or we use angstroms. Kind of looks like the Oakland Athletics symbol there with an A with a little circle on top. And angstrom is 10 to the minus 10th meters, okay? And the frequency, we've already talked about frequency. Frequency is abbreviated nu with this Greek letter. And the frequency is cycles per second. So we can indicate that as a divide by S symbol. We can write it as S to the minus 1 power. Or we can write hertz, like Hertz rent-a-car. Capital H, small z is called hertz, okay? So let's do a problem that requires using both of these formulas, and then I'll give you a summary of all the equations, the constants, and a suggested list of problems to try from the open stacks, all right? So this problem's asking you about violet light, all right? Which means visible light for our eyeballs. And it occurs at 435.8 nm. Nm stands for nanometers, remember, okay? And we want to know what's the energy in joules, all right? So let me just outline the strategy for you. We're starting with the wavelength, okay? And we need to convert that to frequency so that we could plug it into the Einstein-Planck equation, all right? So step 1, we want to convert 435.8 nanometers to meters. So remember again, we use that conversion factor. 1 nanometer is equal to 10 to the minus 9th meters. Make sure you have your units on the correct area so that the nanometers cancel, okay? Now, in step 2, now that we have the wavelength of light in meters, we want to convert the wavelength to frequency using the speed of light equation, all right? So the speed of light equation is C equals lambda times nu. If we divide both sides by lambda, we get nu by itself. Nu is equal to C divided by lambda. So what we want to do is plug these in. The speed of light, rounded off here, is 3.00 times 10 to the 8th meters per second. I like to round it off because it's easy to remember 3.00. And then we divide by the wavelength, which we calculated earlier. This is such and such 10 to the minus 7 meters. And what we get here is, if you look carefully, the meters on top cancels with the meters on bottom. And you might be wondering, well, what about that seconds there? The second stays, and it's a divide by second. Remember that frequency is cycles per second. So this would be 6.884 times 10 to the 14th cycles per second. That's very fast, all right? But that's typical. Frequencies are very high when it comes to electromagnetic radiation. All right, now what we want to do is we want to take a look at proceeding onwards. Now that we have the frequency, if you look at our strategy, we want to convert that to energy, all right? So we just want to plug it into this equation here. Remember that Planck's constant is 6.626 times 10 to the minus 34 joules times seconds, all right? And just that constant will be provided to you, and the frequency we calculated earlier, okay? So the seconds here divides, seconds on the left, and divide by seconds on the right, and we're left with units of joules. And it's a very extremely small number because we're talking about a single particle of light or a single photon of light, all right? So that's how you do this type of problem, okay? Now what you want to think about is maybe the summary here. Useful constants that we're going to be using in chemistry is 2.998 times 10 to the 8th meters per second. I'm writing it out here, not rounded off. And Planck's constant is 6.626 times 10 to the minus 34 joules per second, okay? And we have two equations that we've used. I call it the speed of light equation. The c is equal to a constant, and that's equal times the wavelength times the frequency, okay? And the energy is equal to this constant, right, times the frequency. All right, we did OpenStax problem 4, but I recommend doing problems 2 through 3, 6 through 9, and 11. I can't promise these will be up on my Stoddard Tutoring Stoddard Tutoring channel, but you're welcome to check that out. And thanks for watching. Please like, give a thumbs up, and please do consider subscribing to my channel to support my efforts. Thanks a lot. Have a great day.